Hey guys, welcome to the fifth part of this tutorial series where we were exploring React-Three Fiber and React-Three-Drei. We left our project off at a kind of progress like this where we had a blue colored environment and it was reflecting a light of its own, and then we had a spotlight on the left, some shadows to the right, and our entire object was reflecting, well, these light from the surrounding, the environment, the bluish light, and it also was casting a shadow. So this is what our project looks like currently. In this tutorial, we're going to learn how to use GSAP to animate your object, and it's going to look cool when you add some motion to it. So even if you haven't used GSAP before, don't worry. This video will go over GSAP all the way from the beginning and will help you animate your models. I'm Sohel, and let's get started. So this was our project, our progress currently. So now let's talk about how we can animate this object right in the middle, this ball, how we can do that. Now, if you come back to our code, well, this is what we had, right? Now, understand this, that React-Three Fiber allows you to code in Three.js in a React sort of a way. And what I mean by that is that you have components that then render out to your renderer, right? So say you want to animate some property within the ball, like I just showed you in the last tutorial, where everything has their own properties inside. Like this car shadow itself is a property on its own. And the way you would have done this in Three.js is that you would have simply taken the mesh object and set the cast shadow property of it to true. Now, so one of the many ways in which you can pass parameters to any component here is to simply pass a prop. Well, there's another way you can do that, and that's simply the React way of doing it. All you want is a reference to this ball right here, the mesh of the ball right here. And then all you need to do is just use a use effect, access any property within that object of the ball, and just animate it. And what do I mean by that? So let's see here. I'm gonna comment out the code. Let's comment out this portion of the code, that is go to move the camera around. All right, now let's create a new section of our code. Ideally, you would create your own custom hooks for this, but in this tutorial, we're not going to go into too much into React because it's going to be a tutorial about Three.js and React-Three Fiber, so you can figure things out on your own. So I'm going to write, what do we call this? Animation. Let's just call this animation. We have a use effect, and what we are going to do is that let's call this ball ref, and we'll use the user ref hook from React. If you don't know what the user ref hook is, user ref hook returns you a reference to any component that you have, and it's not just component. User ref is just any value that you want to persist between renders, and in this particular use case, we want to persist the pointer to the DOM element, to the component inside the canvas. It's not a DOM element, slip of tongue again. But yeah, so we want to persist a pointer that always points to our ball component, or more specifically our ball mesh, because we want to use that pointer to get access to the properties of the ball that we want to animate. So you need a reference. Once you have the reference, we'll pass the reference just like you do in React. You just pass a reference. Well, now you have access to the ball ref. Now you have access to the ball mesh. You take this and let's make sure that, yeah. Now let's add a small condition which says that ball ref.current must not be null in order to progress with our animation. I think GSAP is already installed. Yeah. So let's start with our GSAP. You know what? Before starting with GSAP, let's just log ballref.current to see what exists inside it. Let's just do that. Console.log ballref.current, save, and we do have a ball ref here, and that is the mesh, like I said. So let's look at some of the properties. Remember, we set cast shadow to true. Well, look at this. Cast shadow is set to true here. But then there are several other properties. Since it's a mesh, you also get access, direct access to the material you use to construct the mesh. So, well, if there's material, it makes sense that there would be the geometry as well. But here's the geometry just above it. You have several other things. The one we want to animate in this video is the position, but you could animate any property that you see inside this. Well, we have position, okay? We have an x of 0, a y of 0.5 that we set, because remember, it was originally every mesh would be at 0, 0, 0. We have to raise the ball so that it doesn't appear to be going into the flow. So this is what our position is right now, a 0, 0.5, and 0. That makes sense. But there are other properties as well. There are quaternions for rotation. There is Euler rotation for again rotation. And yeah, so let's start with animating the position. Let's start with that. Now what I'll do is that I'll just leave the console log here for now, and I'll say uh, x-axis motion. So what we are trying to achieve is that we would start with the ball starting from somewhere to the left, and it would animate into its place, or maybe further towards the right by the end of the animation. So we're going to do that. So it would look as if the ball was dropped to the ground and it's going forward, and then it stops. So let's try to create that effect. Let's try to brainstorm our way to make the effect as realistic as possible. So the way you can do that is, the first thing you need to do is import GSAP. GSAP is a wonderful animation library that just makes it very easy for you to create your own animation that you would, well, if you wanted to create this sort of animations on your own, you would have to use lots of render loops and lots of mathematical calculations to make things realistic. But GSAP just has it right out of the box. So we're going to use GSAP. Is GSAP imported correctly? Import still has GSAP. Yeah. So now we have GSAP. GSAP is a collection of several methods, and all they do is that they take a value and then take some data that states how the value should be changed, and then it changes the value with respect to time, and then that value itself, if it happens to be a property of some other thing, then this property looks to be looks like it's being animated. So think about this. If the x position of the ball is, let's say, currently 0, let's assume it's 0, and you tell GSAP, well, make the x position to be 3 in under 2 seconds. So what you're gonna see is that it animates from smoothly from an x0 to an x3 within 2 seconds. So GSAP is going to do the interpolation for you. You don't have to customly keep changing the x coordinate. GSAP will do that for you. All you can do are, well, there's two kinds of things that you can normally do. You can either use the do function, and wait, did we not correctly import? Hold on, where is the? I'm probably. Well, I think autocorrect's not working anymore. Nah. Whatever, we're gonna continue with this. Okay, so what the do property allows you to do is that it takes the current property you have, and then it allows you to mention another set of value, and then GSAP will animate between the first and second value. Let me show you. Say, for example, that you have, let's take an example. Let's say you had a variable x equals 3. You have the x to be 3. If you write something like, I really needed the autocomplete here to, kind of explain stuff, but it looks like I'm gonna have to manage. So if the x value was 3 and you wanted the x value to end with 5, well, you could easily do that. Say, for example, that you want your own duration to 2, and say you want the x value to be, well, 3. I think, is this a correct way of doing it? Well, hold on. What if you wanted to change an object? Let me just let me just show you with a live example. I think that would make a lot of sense. Seeing this in real action. We have ball_ref.current, right? Ball_ref.current itself is an object. So what if we do something like GSAP to stupid autocomplete ball_ref.current, and inside the ball_ref.current, well, we want the position, right? We want to animate the x of the position. So let's go one step further and type here position. Well, now we have access to the position. Position itself has three other keys inside it: the x, the y, and the z. We're interested in the x. So we're going to do something like x. And current x is 0. Let's shift it to 2. Okay, so we have the value of x that all GSAP will do is that it will see the initial value of x, which happens to be 0 right here, and it will look at the destination value of x, the final value of x, what it should animate the value to. So that is, well, x equals 2. And then you can specify several other properties. So you can specify a duration. Say I want the animation to be over within 2 seconds. We have x equals 0 that should change to x equals 2 with 2 seconds of duration. What if we do something like this? We save, and gsap.to is not a function. Probably okay. Let me refresh the page. Nope. Like I said, there's something wrong with GSAP. Maybe I shouldn't have imported from this. Maybe GSAP itself is a default export. Is it? Yeah, I was correct. Excuse me. I was wrong. Okay. So we have gsap.to, we have the position, and we save it. Now, okay, that's fantastic. The ball appears to be rolling. If we let's work on this a bit more, let's just make it a bit better. We start off at a -2, and the spotlight was at minus. Let's increase the distance a bit, and the ball should animate to an x of 1. Let's make that happen. Okay, how does it look? Quite good. Light's too far away now. I think the light's way too far away now, so let's make that correct. It's just me playing around with the value. You feel free to put whatever you want. I'm just gonna do things, my way. We have the ball that starts from a -2 and it goes to a yeah, it looks fine. Yeah, it works. Yeah. So we have the ball that started from here, and if you see closely, the ball doesn't travel with a linear velocity. What I mean by that is that the ball appears to slow down with time. It doesn't just go and then stop all of a sudden. It slows down gradually. Watch again. See? It slows down gradually, and that's because there's something called the easing. What the easing is simply, well, there are different ways you could explain easing. Well, let's think about it in this way. You have progress of the animation and you have time. If you take them on, let's jump to GIMP. Let me just show you. It's better if I just draw a graph and show you. So let's just choose any color. We have this. Now, say this is time and this is progress. What I mean by progress is that if you have an animation, the more you have of progress, the more you are coming to the completion of the animation. So say for example, if we were just rolling a ball, when progress is 0, it means that we are at the beginning of our animation. If the progress is at 100, it means that we are at the end of our animation. So what easing does is that it decides at what rate should progress change when time changes. Now, just look at this. If the graph looked like this, it would mean that with equal passage of time, the progress increases linearly. Let me show you the real uh, visualization. So if I set the ease to be linear, which means the ease is now a straight line, you're going to see something like, observe, and the ball stops all of a sudden. There is a slowing down. The ball just goes. If you look at the animation again, it goes and then it halts all of a sudden. That smooth stopping is now gone, and that's because we just reduced our graph to this. The kind of animation we had before was what's called an easing out animation. What easing out means is that it eases or slows down on its way out, which means on its way to the end of the animation. We want that. So what we want is to make our graph, let me draw this in the correct way possible. We want our graph to be this, not a straight line, but you see that we do travel quite fast when it's in the early stages, but as time passes, we want to slow down so that the last few percentage of the animation takes a longer time to happen. That means we're slowing down here, we are like speeding up here. So if we change this to an ease out, and is it ease out, or let's save it, let's find out if it's ease out, or we're just gonna have to read the documentation. Let's refresh, and now it eased out. If you saw that, let's refresh again. And it eased on its way out. Well, logic dictates that what if we choose ease in? Well, then you will see that it starts slow but ends very fast before stopping abruptly. Because that's what we did here, right? So it starts quite fast. Did we save it at all? I think ease in doesn't work, does it? It's still easing on its way out. Huh. Let's read the documentation to figure out the different easings. Ease. And let's look for version. I think it's this one. Well, let's choose this one. Come on. Now it's version 2. We need version 3 of easing. Come on. My connection is horrible right now. What's even happening? Come on. Okay, we have that. And easing didn't. Okay, we have easing. So we were trying with linear before. aka none, aka power 0, whatever you want. There is no ease in, ease out. I mean, I think they're using some different sort of name for it. I mean, you call it an ease in or ease out. If you use CSS, you would have, well, you know. But I think it's known by a different name here. So I think we need a visualizer. So if you just Google GSAP ease visualizer, they do have a beautiful visualizer that you can use to just visualize the different easing effects that you have. I think this is the version 3. Which one of this is the version 3? Is this the version 3? Let me see. Yes, this is the version 3, and they have different easings. The one we wanted, well, okay, they have. Alright, that's what they have renamed it to. It's not easing out, it's power 3 or power 2 or power 1, power 4, dot out. So that's what the term they used. Okay, fine. And just look at this green color dot here. That is what the easing is. So this is smoother, this is more, well, more pronounced. And we have elastic. Beautiful. We have bounce. This is going to be useful. And you'll see why. We have rough. Okay. Okay. Huh. We have lots of it. We have sign. Okay. That's useful. This is the old documentation. Yeah. Don't follow this one. It's for V2. You should use V3 of GSAP. Okay, and what if we choose none? Well, none is linear. If we erase this, I think it defaults to power 2 or power 3 out. So we're not gonna mess with that now. We'll say save and we'll keep this page open in case we need to come back here. Refresh and our ball should animate. Beautiful. And I think we should change the easing to, it's again me fumbling around. Let's keep power 3 dot out as our ease. So we'll say ease is power 3 dot out in a string, save, and let's look. Well, now it's happening much faster. I think power 2 would have been better. Yeah, I think power 2 would be better, not power 3. It's happening way too fast. Let's see. Okay, we'll go with power 2. So we have this kind of a motion. The ball is going from a negative x to a positive x, and that creates this illusion of animation. And I call this an illusion because it's not a real animation, right? What GSAP is doing internally is that it's changing the x property of this object right here with respect to time. It takes 2 seconds and an ease of this to animate whatever x we had, that is minus 2, to a value of x1. That's what GSAP is doing. Well, you could have used another, well, GSAP has lots of function. There is the from function. And the from function works opposite to the to function. What the to does is that it takes a current value and then it animates it to a chosen value. From is the exact opposite. What from does is that it takes a value that you want to animate from, and then the end of the animation has the this value, the default value, as the end animation. So you have these two opposites of one another. So what, in place of 2 you could have also used something like, well, if you had x as 1 here, which is the end result, you could have chosen the from here to set an something like ball ref dot current dot position, and you could have set this to an x of minus 2, and you could have animated this to an x of 1. So from minus 2 you have 1, and this would have worked just as well. And I'm gonna make, or you could use maybe from 2 that allows you to specify both a from and a to with their own easings, durations, and stuff. So we could definitely do that. Okay, we're gonna add another animation, and if you don't know, you see, in the real world you can combine animations, right? I mean, say for example, look at the earth. Our earth is rotating around its own axis. At the same time, it's revolving around the sun. So you have these two motions that are happening simultaneously, and the effect we get is a combination of all of these individual motions summed up. So what I mean by that is, let's imagine a scenario like this, where we're combining two different motions. Say we have a motion number 1 where the ball is going to the right hand side from the left hand side. That's motion number 1. And let's say we have another motion where the ball is dropping from a certain height all the way to the ground, and that's motion number 2. Well, what if we combine them? We would get something, if you think closely, we'll get something like the ball would bounce. Okay, the ball would bounce. This is what we'd get, right? Because observe, this has the x motion that we had here, as well as the dropping motion that we had all the way from the top to bottom. If we consider that this ball would go up again, and then it would come down again, and then it would go up again in a bouncing sort of motion, up and down, like if you drop a ball from a surface. So if we combine these two motions, this is what we get, and it happens in real life. I mean, it's a real life phenomenon, and the way you do in Three.js is very similar. You have two different motions working on the same object, animating 2 or 3 different other properties, and then you combine them, and you create a combined animation. So we're going to create this effect. Right now we have animation number 1 complete. Let's look at animation number 2, but let's think about this for a while. We have, let's call it this, the x-axis motion. And let's animate. I think the ball was 0.5. Yeah. So let's do it. Let's have GSAP 2. We'll have the ball ref current dot position. We have the Y that's now separate, and I want it to. Let's now start at 0.5 because we're dropping the ball from above. So I want the initial to be something more. I want the initial to be 2.5. And I want it to animate all the way to 0.5 in the duration. What should be the duration of this? Let's make it, I don't know, 0.75 seconds. Let's just play around with the value. So it drops from above to below. It drops from top to bottom. But you see, how can we simulate gravity? Well, it's not space, right? This environment, we want it to behave as if it's Earth. So what gravity would do is that it accelerates objects. So it's slower when it starts dropping, but faster by the way it reaches the ground, right? So we're going to have to accelerate. Well, what's acceleration? Well, acceleration is that you are increasing the velocity with time. In other words, more of the animation takes place at the end of the animation than the beginning of the animation. And that's easing. We could use easing with that. So it starts off slow and ends very fast. We can easily achieve that with easing. So what we can do is, I think we have a type ease in. So we could go with an ease in, and what of this would represent our ball? Let's try. Ball dropped and then it accelerates. Very slowly and then boom. Very slowly, and there you go. Can we use this? I mean, it's way too. Let's try this. Or let's try this. I think we'll go with a power to, let's try a circle. Nah. Let's try with an exponential. I think we're gonna have to play around to find what works the best. So we're gonna have an easing. Let's start with a power 2 in. Save. And let's try. And we don't have these two animations happening simultaneously. Oh, and the reason is, well, these two animations are not conflicting with one another. I mean, I just said, well, you could add two different animations. Well, you can. But what GSAP gets confused about is that you are both trying to access the same object at the same time. So it can only take one at a time. So if you refresh it, looks like it's taking the last one. See this? It's taking the last one. So what we can do is use something called a timeline. A timeline is what GSAP will use to schedule your animations. Let's see if this works with timeline. So what I mean by scheduling is that if you have ever worked with a video editor before, you would have seen something like, let's just clear all of this out. Yeah, you would have seen something like you have a giant timeline here, and then you have, well, let's say you have an effect from 3 to 5 seconds. Let's say you have another transition from 14 to 15 seconds, and so on. So this thing is called a timeline. And in animation, you have a similar timeline that you can, programmatically configure to start, stop, pause, rewind, or whatever your animations. You can do that. So we're gonna do now. First thing we need is our timeline. So just comment it out. We'll say timeline is our new GSAP dot. Is it timeline? Yeah, but we don't need a new keyword. Yeah, it's just a timeline. So we have a timeline. We'll replace GSAP but the said timeline. The two method will still work with this. But there's another thing that we can pass now, a third uh, parameter. What we had before was the object and the new values. We can pass now another parameter, and that states the position of the animation in the timeline. So what I mean by that is that, say this is transition number one, this is transition number two, or you can call this animation number one, this is animation number two. What if you want the animation number two to start 3 seconds after animation one? What if you had this constraint? Well, you can do that if you set not this. Say this is animation 2, you want that to be, I think this is the symbol. Let's just have a quick look. I'm going to explain to you the meaning of the symbol, obviously, but let's look at the documentation to see if I'm doing this correct. GSAP timeline. There is always a documentation to just consult if you ever forget something. So just don't try to cram things. I don't like cramming. So yes, timeline, and let's look at this. Is very important. And you can use symbols to denote when an animation should start relative to the animation before it or after it. And see this. When a number follows this, it is interpreted as relative. Yeah, let me just mm, mm, mm. seconds, and I think this is what it is wanting to say. Yeah, look at this. You use this symbol to specify that the current animation should start when the previous animation started. This is the meaning of that symbol. This symbol is the opposite of this one. It shows that the animation should start at the end of the previous animation. And then you can set different offsets if you want to specify some delay. So for example, in our example, if we wanted a delay of 3 seconds, we would be using, I think it's this symbol, all right, but we need some delay with it, and I think it's plus equals 3, or I think it's the same as this, so that is implied. All right, so we can use something like plus equals 3, and what this would mean is that start this animation 3 seconds after the previous animation ends. And how does GSAP know this is the previous one? Well, because this one you scheduled before. This comes before this. If you happen to just cut it, paste it here, then this would become the first animation. This would become the second in timeline. Let's see if this works. So what should happen is that we should see the X motion, and we should see a 3-second delay before seeing the Y-axis motion. Let's see if this works. Refresh, and it still doesn't. What are we doing? Wait a minute. It did work. And after a 3-second delay, it does come back. So this animates. What's wrong with this? That is strange. Huh. Let's try to, I think, let's start paused. What the paused property allows you to do is that the animation, the moment you schedule it, the animation would start. We don't want that. We want to schedule first and then play when everything is ready. So let's see if that fixes it. I honestly have no idea why it doesn't work. But yeah, let's play it. So it starts paused, schedules the animation, then plays it. If we save it now, this should work. Let's see. It still starts at am I the only one? Wait a minute. That is very strange. Why does that not work? Let's see. That is strange. It's as if this property doesn't animate. Why is that? Ball ref, current, position, X should become 1. But who changed this? The x is already at 1. Oh, I didn't change. I forgot to change this when I was explaining. God damn it. Oh man. Oh, bugs. So, yeah. It will start from an x of -2 to an x of 1. Let's save this one. Yeah. Perfect. We have x motion. You see that above? It's going to wait 3 seconds and then it's going to drop. Perfect. So now if we don't add this delay and we say that we want both of this to happen at the same time, that means the start of this animation coincides with the start of the previous animation. Means we want to start two motions at the same time. If we save it and let's look at it, yeah, it looks like it's dropping from above, right? I mean, it has the x-axis and the y-axis motion combined. Watch again. Okay, that looks, yeah, that looks good enough, does it? Yeah, that looks good. But we want the bounce kind of animation, like we had previously discussed. We want the well, bouncing again and again. The way we could do that, well, the simpler way of doing that would be just to use the bounce of this, right? And what it does is that if I play this again, it bounces on its way in, but I want the opposite, so it bounces on its way out, just like a ball would. So we could use bounce.out to simulate the bounce motion. So let's see if we can do that. We don't want a power 2 in, we want a bounce out. Let's try. With a duration of say 1.5, we could do that. Let's see if this looks realistic. Okay. The one thing I hate the most is that you can't customize the bounce if you wanted to, can you? I mean, you could use the visualizer to create your own easing, I think. Can I click anywhere? Come on. Okay. We have a custom. Oh, awesome. We can. Look. Holy shit, that's a big ease. Okay. Looks like we don't have to create our own bounce animation. But let's fumble around a bit. I mean, you know me, right? Once I see something, I'm gonna experiment it. So we could just go with bounce.out and I have a lizard on my wall. What the hell? Okay, let's continue. So I'm gonna continue. Well, you could use a bounce out and well, there you have it. You have your bounce animation. I'm gonna take this one step further. If you want to stop this video right here, no worries, you've learned all that I wanted to teach you today. But if you are willing to stay, please do and watch me fumble if you want to. I'm gonna create the bouncing animation but on my own and make use of the timeline properties to show you how you can schedule your bounces mathematically. You can see that. So let's undo what we had. Let's refresh and it should drop in an arc. Yeah, it should drop in an arc. Let's decrease the ball height because it's dropping from way above. Let's make it 1.75 so it drops from a lower height. Yeah, I think it does drop from a lower height. Let's decrease the height even further to a 1.5 and let's look at this. And we need to fasten the animation, so let's decrease the duration to a 0.5 and yeah, I think that does it. Okay, now let's think about the bounce animation in sort of physics, with respect to physics. Let's erase the timeline and let's look at the bounce again. We have the ground here. Now, let's ignore the x-axis, the x motion for a while because we're focused with the bounce and the bounce occurs in the y-axis. Like I said, you can separate out the motions and you can program them individually, then combine them and it creates a realistic effect. So let's forget the x for now, let's focus on the y. If you drop a ball, say from this height to this, in the real world, the floor would absorb a specific percentage of the initial energy. So when the ball would bounce back, you wouldn't see it bouncing back to the same height as before. You wouldn't see that. The floor would take up some of that energy. So you will see the ball rising only to a fraction of the original height. Maybe this is 80% of the original. Now if it drops below, you'll see that the next time it comes up, it's going to drop to maybe 80% again of the previous one, like so. This is how bounce happens, right? And then it's going to be even lower than that, and then it's going to be even lower than that, and it would continue until it would just come down and never have the energy to rise up again. So this is the kind of bounce animation that we want to create. Observe that this has a timeline of its own that you can use GSAP to do it. You have the first animation, okay? Step 1, first animation. Step 2, well, cut out some amount of initial height from the previous height, right? And let's say you're cutting out 20%, so you are left with 80% of the height. Well, animate to the 80% of that height, come down again, animate to the 80% of the previous one, come down again, and you keep doing this in loop until you settle down. So let's see if we can create that sort of effect. We have the initial dropping in ready. Okay, that works fine. Now we have to create a loop and schedule one after the other animation. The current height we have is a 1.5. Okay, we have 1.5 now. Let me create 3 bounces. Let's try with for let I. It's just JavaScript at this point. Smaller than 3 plus plus. I'm gonna start with 1. I mean, I need a positive value this time, and I'll go to a 3. Okay, and you will know why I said this to be a 1. So this shows the number of bounces, right? This shows bounce 1. It means we are the first bounce, meaning we are here. When you are here, you want to set, let's say, let height. It should bounce back to. Well, it should originally bounce back to 1.5 if there was no loss of energy, but there is a loss of energy, and let's consider our decay factor. Let's have another something called the decay factor. Maybe decay factor. I don't think this word is really used in physics. I don't know if it's even called a decay factor. I think it's called the coefficient of restitution, if I remember from my 11th standard. I used to love physics back then, but it's been years and that ship has sailed a long time ago. Decay factor, we have that. And we're going to set it at 80%, which means 80% of the energy is conserved, 20% of it is eaten away. So we have a decay factor. Let's just call this coefficient. You name it whatever you like. It really doesn't matter. Name it A or B for whatever. Call this 0.8. So at every iteration, the first thing we want is to calculate the new height, which is our coefficient multiplied by the height. So we have the new height now, and once we have the new height, we have to animate back to that height. So we will copy this thing here because I'm lazy. We're going to replace y by that height. We will keep the same duration. And now we're animating it to a y, which means we have to do the reverse ease, which means that we want, like, if an object drops from above, it accelerates by the end of the animation. But if it goes from bottom to top, it decelerates when it reaches the end. I mean, it slows down as opposed to if the ball was dropping, then it fastens up, right? So we're going to go with the power to out. So it eases on its way out as if it's going up, stop. That's what it did. And we are going to change to this symbol, which means this animation should start only when the previous one has completely ended. So we're going to do that, and then we're going to schedule another animation. Okay, let's leave it a few lines of comment. This is going up, this is coming back down, so coming back down, and it would also come back to the same height, which is 0.5. So we will copy this line here, paste it here. It would happen at the end of this previous animation, correct? And it will come down to a 0.5 again. Same duration. This time it's an in animation, and there we go. I think we have it. It runs in a loop, so you have two different iterations. And wait a minute, we do the height. I think we can make this sort of okay, this is just the mathematical part of it. We're multiplying the coefficient of the height to make the new height every time. It means that for first bounce, we need to multiply coefficient. For the second bounce, since the height has already reduced, we can simply multiply the new height with the coefficient. But if we don't want to store this height in the first place, let's do away with this. We don't need this. We have the coefficient. So what if I take the original height and just say this raised to a certain power? Well, we could do that, and that would be the same. Math.pow coefficient multiplied by the iterator. And that multiplied by the height will give us the new height for every instance. And this thing, the height is now 1.5, and we'll cut this out and set it here, and we don't need this. Perfect. Going up, coming back down, and that we should be good to go. Let's try. Save. Okay, it definitely looks like we are on the moon. Okay, definitely not what I thought, but can we work it out? I mean, there is a way you could make this even more realistic, but that's too much maths and that's over my head. You could just simply use the bounce ease to make your life easier. I'm just thinking, what can I do to make this more realistic? Right now we see that it's taking too much time to get over. So what if I decrease the duration? What if I make it 0.1? What if I do this? Will this work in the first place? Holy shit! The ball's on steroids. Let's look at this. Nah. Let's look at this, and let's increase the number of bounces to 5. Let's say it's gonna bounce a lot. We have a big bouncy ball. Maybe just a bit decreasing on the distance. No, let's increase the bounces. Let's have 7. Let's see. What? Okay, that was a strange animation there. We're gonna go with 4. I don't see anything. I mean, I know what's the problem. When an object bounces, not only does its height decrease, but the rate of its bouncing also increases with time, I think. But now we're going all the way to classical physics. But this is supposed to be a tutorial on animation. Now we're going into physics. What am I doing? Okay. Well, now you know if you wanted to create your own bounce effect, how you could do that. But this looks horrible, and I'm not going to go with that. But now you know how you can schedule timelines, right? I mean, well, you just This is the takeaway from here, that you could schedule your timelines even with the loops and it would get set one after the other, and you could use your own offsets in order to mention how many seconds you want to wait before starting the next animation, just like you would do in an actual timeline. We will erase all of this currently, and we will replace this by, it was bounce, right? It was bounce on its way out, and we'll increase the duration of this to a 2, so both of these end at the same time. We'll save, and let's look at this. That wasn't great. Okay, we're gonna go with a duration of 1. Am I even doing that correctly? Yeah, this looks so much more realistic. It looks like some of this 3 or ball. Way more realistic. Yeah, we're gonna go with a bounce.out animation. Yeah, so that is it for this tutorial. I think we're in a pretty good position, and we're approaching the end of this tutorial series. This is the second last video. In our next video, we're going to explore how you can bring your own models. What I mean by models is that sometimes what mesh you want is very complicated to create with primitive meshes that three.js offers. You might want something complicated. Say, for example, you want a house over here, a 3D house straight out of Blender. If you want that, I'll show you that in my next tutorial, because it's already been way too long for this video. So stay tuned, like this video if you really liked it, or leave a few comments, or you can connect with me on Twitter, and well, I'll be happy to talk to you guys, and I'll see you in the next video.